Radio, guys, part 3. So, yeah, sorry, it ran out again. So we've got a pentagon, and again, I've just gone through and written stuff because I'm just trying to fill in the time because it takes ages to load onto YouTube. So we can split this pentagon into 5 equal segments. Okay, we're told it's regular, so we know that they're all equal. Each segment, each big isosceles triangle can be split into 2 right-angle triangles, and from there we can do stuff with it. So we've got our triangle drawn up the top of the page here with 14 long, and we've worked out that angle at the center. Of course, we can work that out because we only had the one measurement that we could deal with, and that was the 14. We didn't have anything else really that helpful, but we can work out this angle here because around the middle there that I was doing in red, we've got angles at a point adding up to 360, and we'd write that reason down because angles at a point add to 360. We can divide it by 5 because there's 5 equal angles there. So each one is 72, the top of each isosceles triangle. And then, of course, because we're only using half of it, exactly half, we've got 36 degrees. So that means that corner there is 36 degrees. So you'll see here, I've drawn a little right angle triangle. That means, so we, thinking about what we actually want to find out, we want to find out the area of triangles. Okay, we want to find out the area of the little triangles. So we need to think about what we need to find the area of a triangle. So we normally, to find the area of a triangle, it's base times height, and you divide that by 2. Okay, base times the vertical height. For a right angle triangle, that's nice and easy. So it's this length here that we want to find. We can call it A. In this case, you'll see that, well, if we use trig, it's just going to use tan. Okay, we've got opposite and we want to find the adjacent, so we can use tan. So if we use tan, go through, you'll end up with 19.269. So that's telling us how long it is. And then if you're clever, rather than what I did, if you're clever, you'll go, oh, okay. So if this is 19 centimeters long, then this, the length we actually want to know to find the area, must be 14 point whatever centimeters long because it's just 5 centimeters shorter. I first of all actually calculated the area of the large triangle, and of course, because this is a 3-hour exam for a 1-hour topic, doesn't matter if you do the same kind of thing because you've got plenty of time. So I worked out the area of the large one, and then I went, however, we need the area of the shaded one. So anyway, yes, we work out that actually the height that we can use is 14.269. So that's the height that we want. And we go, okay, so that's the height of the shaded triangle, the smaller triangle. But hang on, is that base of it still going to be 14? And it won't, will it? Because this is shorter than this. It's definitely shorter. So you're going to have to repeat the same thing again. Okay, you've got 36 in your angle here. Okay, we've got 14.269 as that sort of height of it, but we don't actually know this last length here. So use tan again. This time you're using it in the opposite ratio, and you're going to end up with 73.9, with 10.367. Then you can do your area, so your 10.367 times your 14, blah, 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 divided by 2. Okay, base times height divided by 2, and you get 73.9636 centimeters squared. Because there's 10 of those little triangles, I then multiplied it by 10, okay? And you'll get around about, because there's a few different calculations that happen, and the answers, they've been rounded a little bit more earlier, but you'll get somewhere in the margin of sort of 738 to 742, 43. Okay, centimeters squared. And that's excellence, that one, wasn't it? Hang on, let me triple check again. Yeah, that was, wasn't it? That one, does seem like a decent excellence. It used quite a few different bits and pieces to it, okay? You have to show that nice chain of reasoning to get excellence, and of course you also have to find the area, okay? And notice that they say allow some rounding errors, because the answer here, 742, that's rounded a bit more than you'd want. Yeah, so anyway, that's a nice one. Next we had a super lovely achieved one, which again I think everybody got right. Oh no, not that one. Actually, that one. No, it's all right. This is the one actually that everyone did really well on. All it was corresponding angles and then corresponding angles. Some people did corresponding and then co-interior. Some people did co-interior and then corresponding. Yeah, it was awesome. Okay, then we've got this wee friend here. So part B. So we're told we've got this tangent to the circle going on here. We're told the center is at O. We've got ACE, which is X. So this is one of those lovely proofs with algebra, isn't it? Okay, so we know X. We don't have any kind of numbers that we're given. We need to find angle EFD in terms of X. So for most of the ones that we practiced with, we were able to start at X and then kind of move on from X. And so we might have been able to calculate something else, and that's blah, 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 2x, or maybe it's 90 minus x or something like that. And this one, we actually couldn't do that straight away. You had to notice a few other things first. So it's quite a doozy. So there are some things, though, that we can notice. We actually end up with 3 right angles in here, and they help us a heck of a lot. So the first one that I noticed was GBC, okay, this guy here in green, because, of course, we've got a tangent going on to our circle, so that forms a 90-degree angle there. Then, of course, the one beside it, same deal, okay, because they're coming from the radius, which is at O. So they are right angles there. The centre, sorry, which is at O, they are radius. So then the other one, of course, which a few of you picked those ones up, but you didn't see this one, and I can totally understand why. But this is a diameter. If I go draw an orange, of course, this line here is the diameter of our circle. So this here is that rule about the angle of the circumference of a semicircle being 90 degrees. Okay, so that is 90 degrees. That's a big, big help. All right, so we've got those 2 lovely little facts. So then we go, okay, what can we work out? Well, because we knew this guy here was 90 degrees, then I can calculate this guy down here, BEC, as being 180 minus 90 minus x, because angles in a triangle, of course, add to 180. So therefore, that makes 90 minus x. Okay, sweet. What else can we do? All right, well, you'll also then notice, actually I'll just get rid of the orange for a tick on there. You'll also then notice that, check it out, we'll do it in purple, that we've got one of the feet and hands guys going on again, don't we? So, since this guy is 90 minus x, then this guy in here is 90 minus x as well, isn't it? So, therefore, finding y is just that 90 that the whole thing was, that BFE was, minus the 90 minus x part, which is there. Okay, and 90 minus the 90 minus x, use your algebra properly, you end up with x. So that's your final answer. Okay, again, that one was a lovely excellence one. Sorry, let me double check again. Yeah, excellence. Okay, you need your chain of reasoning. If you only found one angle with a reason, so it might have just been the tangent and it was 90 degrees, that was worth an achieved mark. 2 of those was worth a merit mark, so it's worth it. It's worth it. Just put in as much as you can. Doesn't matter. Oh, and our last one was bearings. So let's have a look. I haven't looked at this one yet since last week. So what was it? Oh, yeah. So you did need to draw your picture. It's all about cats, isn't it? So we've got a cat stowing away on a ship. Okay. I noticed some of you, and it's a funny one, this one, because it does end up kind of this tiny little drawing up the top of the thingy there. Just redraw it, make it bigger, and do it on the back page. There was, I think, a whole blank page on the back there that you could have used. Just do that if you need to, all right? So I'll walk through this. Let's have a look. So we've got a cat stowing away on a ship. He travelled 8,000 kilometres on a bearing of 305 degrees. So you think about that, 305 degrees, our bearings always go from north. Let's say this is our starting point. We're pointing up to north. It means we need to go all the way around. That's only 180 there, isn't it? All the way around. It's going to be past 270, 90, 180, 270. It's good to know those off by heart. So it's actually going to end up here. It's going to end up pointing in this direction. So that's the direction that the cat went from where it started there. Okay, and it went 8,000 kilometers. So the length of that bit is 8,000. Then on a bearing of 50 degrees, so let's point north again, 50 degrees it went 4,600. So 50 degrees, that's slightly over half of a right angle. So we're kind of like that for 4,600 kilometers. All right. We want the bearing and distance he needs to travel home. What a great question, because of course this happens all the time, doesn't it? When cats end up on ships in the middle of the ocean having to work out the bearings that they need to travel home. But it's still cool. It could be you could be, you could be doing some orienteering or something like that. And it's lovely for our brains. So we need to work out, don't we, the bearing from north, from this point here. So we want to know this angle here, and we also want to know the distance. Right, so I'm noticing straight away, I don't know if you guys can see this too, but of course, thinking of parallel line rules, if we knew this angle in here, we'd be able to work that one out, wouldn't we, with co-interior angles and parallel lines? That could be quite a handy thing to find out. And I'm noticing actually that we can... Oh, first of all, I've realized I haven't even put on the degrees, have I? I haven't put on the bearings that we actually know. So let's just chuck them on. We've got 305 going all the way around the outside there. And around here, we've got 50. Right, we've only got 3 minutes left on this recording, so I'm actually going to speed up here. Right, so if we can work out, just like in the ones that we've been doing in class, how far up we've got to go and how far across we've got to go, then we can work out the hypotenuse of a right angled triangle, basically. Okay. So what I've done is I've sort of color coded them here. The two blue ones are our vertical distances, and our red ones are our horizontal distances. And notice we can use trig. So I've created two little extra right angled triangles, and we can use trig to help work out what they are and create this lovely right angled triangle. So I'll just pause it again and I'll write it down. So here's all the working for you. So, and remember, you can pause this whenever you like, so you can take time to work through that stuff. So what I've done here now is I've created this right angled triangle where I've added our two blue lengths together that we've found. And then for our horizontal distance there, you'll notice that it's this bit in here that I'm trying to find. Oh, sorry, I'll highlight it in pink there. So you actually need to do the longer red value minus the shorter red value, okay? Because we're going to end up with a right angled triangle here. So I've drawn it down below here, and then you'll see I've used some Pythagoras. Okay, so we've used Pythagoras, and that has told us the distance that the cat needs to travel. So our very last step, and you can do either way, it doesn't matter. You could either work out this guy here, and then you can do co-interior angles using parallel line rules, like I said, to tell you the bearing, which will be all the way around here. Or you could instead calculate that top left-hand angle, this guy here, and add that to 90, because you've got that one there. And that's just straightforward trig. I'm not going to tell you how to do that. So you could use, O and A. So you could use tan of theta equals O over A and do it that way if you like. Yay, I've managed to keep it under 15 minutes. So that's worth excellence, of course, that question. You've got your distance, and then you need to go through and calculate the bearing. And I'll write the working on here so that you've got it in the OneNote at least written down as well. So yeah, I should be back on Wednesday. I hope this has been really helpful for you guys. Remember that we've also got some geometric reasoning videos here on YouTube, and use those ones that are on Teams as well. Yay, thanks. I'll probably see you on Wednesday. Cool. Thanks, guys. Bye.